What if everything we thought we knew about the universe was wrong? The James Webb Space Telescope has just captured an image so strange, so impossible, it's forcing scientists to rewrite the rules of time, space, and cosmic evolution. A fully formed spiral galaxy appearing just 400 million years after the Big Bang. That's like finding a finished city in the middle of a construction zone. It spins too smoothly, weighs too heavily, and glows with light that shouldn't exist yet. Is this a glitch in physics or the beginning of a cosmic revelation? What JWST just found changes everything. The impossible image. It was supposed to be a glimpse into the early universe, a place of chaos, heat, and raw creation. But what the James Webb Space Telescope captured was something no one expected. A fully formed spiral galaxy, complete with arms, shape, and order. And it wasn't just old, it was ancient, just 400 million years after the Big Bang. That's like finding a finished skyscraper in a city still under construction. Astronomers had spent years predicting what these early galaxies should look like. They expected clumps of stars, irregular, messy, and young. Instead, this galaxy looked calm, structured. It had the kind of shape we thought took billions of years to build. Dr. Rachel Livermore, an astrophysicist from the University of Texas, said it best. This shouldn't be here, not yet. The galaxy defied everything we thought we knew about cosmic timing. Even more shocking was how detailed the image was. The spiral arms, the central bulge. It wasn't just a suggestion of structure. It was clear, sharp, a mature system glowing with light from ancient stars. This wasn't a baby galaxy. It was something that shouldn't have had time to grow up yet. It's like seeing a full-grown adult where there should only be a toddler. The moment this image was released, it flipped the script. It wasn't just a pretty photo, it was a problem, a paradox. Because if this galaxy existed so early, it meant the universe was forming complexity far faster than we thought. And if one galaxy did it, how many others followed the same path? We didn't just capture light from the past, one researcher said. We captured a contradiction in real time. And when one piece of the puzzle doesn't fit, it forces us to question the whole picture. If this galaxy isn't supposed to exist, what else have we misunderstood about the early universe? A glitch in the universe. The discovery didn't just challenge what galaxies should look like. It challenged when they should exist at all. If something this complex existed so early, then our entire cosmic timeline might be broken. The current model says galaxies slowly build up from smaller parts. First stars form, then decay, and over time they form elements and structures. This one skipped the slow part. For decades, scientists thought they understood the sequence. Stars are born, live, and explode, spreading the materials for new stars and planets. It takes generations. But this galaxy looks like it had already gone through all of that, too fast, as if the universe was on fast forward. It's not just about the galaxy, said Dr. Priyamvada Natarajan from Yale. It's about everything we thought we knew about cosmic evolution. Some scientists are even wondering if something else is speeding up the process. Maybe dark matter, this invisible mass we still don't fully understand, is playing a bigger role than we thought. Or maybe some unknown force is pushing galaxies to grow faster in certain places. Either way, our models aren't keeping up, and that's a problem. The truth is, this galaxy might not be a one-off. It could be the first sign that our entire understanding of how the universe grows is flawed. The foundation of decades of theory, cracked by one photo. And as more images roll in, that crack is getting wider. This wasn't supposed to be possible, said a senior JWST team member. Now we're questioning if our entire timeline is off. And when something forms too fast, it's not just about speed, it's about ingredients. The next shock wasn't just how this galaxy looked, it was what it was made of. Heavy elements before their time. The closer scientists looked at this galaxy, the stranger it got. Using spectroscopy, a tool that breaks down light to study what something's made of, they found something impossible: carbon, oxygen, even iron. These elements don't just show up. They're forged in stars that live and die over millions of years. And yet, here they were, fully present in a galaxy that was supposed to be brand new. In theory, the early universe should have had mostly hydrogen and helium. Those are the first elements. Everything else, what we call heavy elements, comes later. After stars explode, they scatter these ingredients across space. But this galaxy didn't wait. It had those elements already, before the process was supposed to begin. You don't get iron without generations of stars, explained Dr. Wendy Friedman. So how did this galaxy have it already? This forces a new question. Is there another way to make these elements? Could the early universe have had unknown processes that skipped the usual steps? Some researchers are asking whether short-lived supermassive stars could have been born and died faster than we thought. Others suggest an entirely different kind of physics may be at play. Either way, we're now forced to rewrite the rules of stellar evolution. The idea that heavy elements could form so early changes everything, because with them, you can form rocky planets. Water, the building blocks of life. So this isn't just about chemistry, it's about possibility, about how fast the universe became a place that could host life. And it might have happened a lot sooner than we ever imagined. These weren't supposed to exist here, said one spectrograph engineer. But they're not just present, they're abundant. So if galaxies were already structured and already chemically advanced, what does that say about the way we measure time itself? Maybe the clock we're using to track the universe is off. Is the early universe older than we think? The way we understand the time and space is built around one key idea: redshift. The more stretched out the light from a galaxy is, the farther away and older it's supposed to be. But what if we're reading that stretch wrong? Some scientists now think we might be. And that could mean this ancient-looking galaxy isn't young and fast. It's just from a place where time works differently. This might sound like science fiction, but it's grounded in real theory. Some physicists believe that different regions of the universe might experience time at different speeds. These areas, sometimes called time bubbles, could expand or evolve faster or slower than others. So maybe this galaxy didn't break the rules. Maybe it lived by different ones. If time flows unevenly across the cosmos, said Dr. Nyayesh of Shorty, then everything we think we know about cosmic age might be local, not universal. If that's true, our biggest tool, redshift, might be misleading us. We could be looking at a galaxy from a slower region of space-time, one where complexity had more time to grow. Think of it like watching a fast-forwarded video from a different timeline. It looks wrong to us, but maybe it's just on a different clock. That would mean our cosmic maps are out of sync. Of course, this idea is controversial. Relativity, the backbone of modern physics, says time should behave in predictable ways. But if the early universe was filled with energy fluctuations, uneven gravity, or quantum distortions, maybe some patches broke the rules. And now those strange time pockets are showing up in JWST's deep field. Maybe this galaxy isn't early, said one theorist. Maybe it's just early to us. But time alone doesn't explain everything, because this galaxy doesn't just look mature, it moves like one. Its internal dynamics are shockingly advanced, far beyond what early cosmic chaos should allow. Spin, mass, and stability. Galaxies aren't just floating clouds of stars. They spin, they wobble, they breathe with motion. And the way they move tells us how they formed. But this ancient galaxy, it moves too smoothly. Its rotation is calm and balanced, something we only see in galaxies that have had billions of years to settle. That's not supposed to happen 400 million years after the Big Bang. Barred spirals, the ones with central lines cutting through them, don't form early. They require time, stability, repeated internal feedback from gravity and star motion. But JWST caught a glimpse of a barred spiral that looked as if it had already gone through all of that. Galactic bars are a late evolutionary feature, said Dr. Deborah Elmagreen. Seeing one this early is like finding gray hair on a baby. What's even stranger is how evenly mass is spread across this galaxy. Usually early galaxies are lopsided, heavier on one side, full of starburst regions and violent clumps. But here the stars, and even dark matter seem to be in balance. The gravitational tug is soft, not chaotic. It behaves like a well-tuned machine, not a newborn system. That kind of order takes time, unless something else helped organize it fast. This leads to a wild idea. Was the early universe more organized than we assumed? Maybe what we've thought of as a violent, disordered era wasn't so chaotic after all. Maybe gravity had more structure. Maybe matter clumped together faster. Or maybe some unknown force helped galaxies stabilize quickly. Whatever the reason, this isn't just an early galaxy, it's an evolved one. It spins too smooth, said an astrophysicist at the European Southern Observatory. Like it skipped the messy middle. And when galaxies act older than they are, you start to wonder about what's inside them. Because these motions, this calmness, depend on gravity. And that means dark matter. But here, even that doesn't behave the way it should. Not dark matter as we know it. We can't see dark matter, but we can feel it through gravity. It's what holds galaxies together. Without it, stars would fly apart. So when scientists looked at this galaxy's spin and mass, they expected to see the usual pattern, dark matter forming a loose, invisible halo around it. Instead, they saw something strange. The gravity was stronger, tighter, more compact than anything in the modern universe. This galaxy's dark matter halo isn't fuzzy and spread out. It's focused, dense. It holds everything together like a tight belt. That's not what dark matter is supposed to do, at least not this early. And that tight gravity changes everything. It affects how stars form, how gas moves, how the galaxy grows. This kind of gravitational behavior is unprecedented, said Dr. Eric Verlinde, a theoretical physicist known for challenging dark matter theory. So what could cause this? One idea is that the dark matter itself is different. Maybe it had a different state in the early universe, more reactive, more interactive. Or maybe what we're seeing isn't dark matter at all. Some scientists are revisiting theories like modified gravity, which suggests that the rules of gravity change at different scales. That would mean we don't need dark matter to explain this galaxy, just a new way of thinking about force itself. Or the galaxy might be sitting in a weird part of space, where gravity pulls more deeply due to hidden dimensions or fields we haven't discovered yet. Whatever the reason, this galaxy doesn't just look wrong, it weighs wrong. And the deeper we look, the more it warps our understanding of the universe's most basic force. If this is dark matter, one researcher said, it's not the kind we've been looking for. And if the gravity is off, and the chemistry is off, and the structure is off, then what we're seeing might not just be a galaxy from the past. It might be a message from a completely different kind of universe. Chemical signals from the past. The mystery deepened when scientists started picking apart this galaxy's chemical makeup. They expected a simple recipe, mostly hydrogen and helium, maybe a trace of lithium. Instead, they found a surprising lineup of heavier elements, not just carbon and oxygen, but magnesium, silicon, and even rare metals like platinum. These aren't beginner elements. They take time, multiple star cycles, and extreme conditions to form. Normally, you get those elements when stars explode and scatter their guts into space. That happens over billions of years. One generation of stars daisies, another is born, and the galaxy slowly gets more complex. But here, all those ingredients were already present. We're looking at a galaxy that skipped steps, said Dr. Anna Frabel, a stellar archaeologist. It's chemically mature in a universe that was supposed to be just learning to build. The ratios were off too. Scientists noticed unusually high amounts of some elements and strange gaps in others. This isn't what we see in typical galaxies, even today. It's almost like a different set of rules was used to cook up the periodic table. Some researchers are now exploring radical ideas, unknown kinds of supernovae, or even non-stellar element formation. What if the early universe had shortcuts we've never seen before? There's also a growing theory that the energy density back then might have allowed nuclear reactions outside of stars, something we don't see in our era. If true, it would mean the universe had ways to make complex matter that modern physics hasn't even imagined. It would rewrite how we understand the building blocks of planets, atmospheres, and maybe even life itself. These abundances aren't just surprising, one chemist said. They're unexplainable, unless there's a whole chapter of physics we're missing. And it's not just what this galaxy is made of that's strange. It's where it was made. Because this ancient giant didn't grow in a busy city of stars. It formed in cosmic silence. Born alone in the dark. Most galaxies form in crowded neighborhoods, cosmic cities filled with collisions, mergers, and gravitational chaos. That's how galaxies grow, by crashing into each other and stealing stars. But this one, it formed all by itself, no signs of neighbors, no scars from past impacts, just silence. That kind of isolation in the early universe is nearly unheard of. According to the standard, model galaxies need interaction to grow. They form along filaments, huge strings of matter in the cosmic web, where gravity pulls material together. But this galaxy seems to be in the middle of nowhere, far from the usual highways of cosmic traffic. It's like finding a skyscraper in the middle of the desert, said Dr. Mark Vogelsberger, an astrophysicist who studies galaxy formation. That raises big questions. How did it gather enough material? How did it stay stable with the gravitational pressure from surrounding galaxies? One theory is that it formed in a special pocket of the early universe, an area that was denser or more protected than others. Some even suggest this could be evidence of a patchy, uneven early universe, where matter clumped differently in different places. This isolation might explain the galaxy's smooth structure and strange chemistry. It didn't get disturbed, no violent mergers to mess up its balance. But it also means we have to rethink how common isolated evolution was. If this galaxy found a quiet corner to grow fast and clean, maybe others did too. And that would reshape how we think galaxies form, not just through but through quiet, hidden precision. This galaxy evolved in peace, one scientist said, and peace, it turns out, might be just as powerful as war. But even in peace, this galaxy was never truly quiet, because its light is speaking volumes. And what it's telling us breaks all the rules of physics we thought we could trust. Light behaving strangely. Light from this galaxy doesn't just shine, it behaves in ways that don't make sense. Scientists studying its emissions noticed unexpected shifts in its ultraviolet and infrared signals. They didn't match the classic Doppler redshift pattern. Instead, the light fluctuated, almost like it was pulsing or echoing. Something about this galaxy's glow didn't line up with what we know about how light travels across space. Normally, as galaxies move away, their light stretches, redshifted by distance and speed. But this galaxy's light showed strange oscillations. Some frequencies jumped. Others faded in unexpected rhythms. It's not noise, it's a pattern. One scientist can't yet explain. We're seeing cycles we've never recorded before, said Dr. Olivia Harper, a JWST spectroscopy lead. It's like the galaxy is whispering a message in a language we don't speak yet. One wild idea? That we're witnessing quantum-scale interference, amplified to a galactic level. In theory, light can bend and overlap in strange ways. But for that to happen at this scale would mean something dramatic is affecting the fabric of space itself. Another theory points to gravitational lensing, where light is bent by massive objects. But in this case, the distortions are inconsistent with known lensing patterns. It's like the light is bouncing off something else entirely. Some have gone even further, suggesting multiverse echoes. If space is curved in certain ways, light might cross through folds in reality, bringing signals from parallel universes. It sounds outrageous, but in a universe where a 400-million-year-old spiral galaxy already exists, the door to wild theories is wide open. The light from this galaxy isn't just old, one physicist said, it's unnatural. And that's what makes it so important. So now we've seen a galaxy that looks too grown, spins too smooth, weighs too heavy, and glows too strange. What if all of this isn't a bug in the system, but a sign we've misunderstood the system itself? Are our models just projections? With every image JWST sends back, it becomes harder to believe that our models still hold. If one galaxy had broken the rules, we might call it a glitch. But now it's starting to look like the glitch is in us, in our maps, our measurements, maybe even our fundamental assumptions. What if this galaxy isn't breaking the rules, but showing us rules we never knew existed? Some physicists are now turning to ideas that used to sit on the fringes. One of them is the holographic universe. The idea that what we see in 3 dimensions might just be a projection of information on a distant, 2-dimensional surface. It's complex, but the takeaway is simple. Reality might be more illusion than substance, and anomalies like this galaxy might be projection errors in that system. The universe, as Nobel laureate Gerard T. Hooft once said, may be a giant hologram. Another concept gaining ground is conformal cyclic cosmology, a theory by Sir Roger Penrose suggesting that our universe is just the latest in a series of cosmic cycles. In this view, each universe ends in vast expansion, then gives birth to the next. And what if this galaxy is a leftover imprint, an echo from a previous cycle that somehow bled into ours? Still others whisper the unthinkable. What if we're inside a simulation? A hyper-advanced artificial reality where these bugs are clues. Some theorists point to the mathematical patterns in the galaxy's structure, too clean, too perfect, as signs of engineered physics. As unsettling as it sounds, we're facing data that seems to fit better with simulation theories than natural randomness. The rules we live by, said one cosmologist, might just be local code patched. But the plot thickens, because this galaxy wasn't alone. JWST kept looking and found more, many more, and that's when a quiet anomaly became a screaming pattern. When coincidence becomes pattern. At first, scientists thought they had discovered a rare outlier, a 1 in a million accident, but as JWST scanned deeper, it kept finding others, galaxies that looked the same, ancient, spiral-armed, chemically rich, structurally perfect. And just as impossible, the impossible galaxy wasn't one miracle. It was part of a trend, a silent, repeating message written across the cosmos. In total, dozens of early galaxies are now showing these strange features. That includes stability, chemical maturity, and gravitational patterns that don't fit standard cosmology. They're not all carbon copies, but they rhyme, too many to ignore, too organized to dismiss. This isn't noise, said Dr. Brant Robertson, an expert in early universe structure. It's signal, strong and undeniable. This repetition raises 2 possibilities. 1, the early universe was radically different from what we thought. Faster, smarter, more structured. Or 2, our entire framework, our cosmology, is incomplete. That's a heavy accusation. Modern cosmology is built on decades of theory, math, and observation. But now that structure is cracking. Not from opinion, but from data. What's even more haunting is that these galaxies don't just challenge time and space. They challenge chance. The odds of these patterns forming by coincidence? Astronomically low. And yet, here they are. Some scientists have started calling them the constellation of contradiction, a poetic name for a data set that's slowly rewriting everything we thought was settled. It's not that the universe is random, said one astrophysicist. It's that we misunderstood the pattern it's been following. And when you start seeing patterns, you start wondering what they mean, not just for science, but for us. Because if galaxies could form faster, what else could have? Life before Earth. If these galaxies really were chemically mature so early, it means the raw ingredients for life, carbon, water, metals, were also ready. That flips a switch. It means that rocky planets, atmospheres, and maybe even biology could have formed billions of years before Earth. In other words, life could have had a head start. In these ancient, forgotten galaxies, entire planetary systems might have already come and gone before our solar system was even dust. We often think of Earth as early in the story of life. But what if it's late? What if life didn't just have a head start, but a full lap ahead of us? We may not be the first, said astrobiologist Dr. Sarah Seeger. We may be among the last. That brings up something rarely discussed: extinct civilizations. If life had billions of years to grow before Earth formed, who or what might have risen? Could alien civilizations have lived, evolved, and vanished in that lost time? If so, their traces could be hidden in those galaxies. Maybe not in radio signals or spacecraft, but in subtle chemical footprints, planetary scars, artificial element ratios. This doesn't just widen the scope of astrobiology, it deepens it. It means we shouldn't just search for life. We should search for its fossils, across light years, across time. It's no longer about looking for alien neighbors, one SETI researcher said. It's about looking for ghost towns in the stars. The past might be full of life, one theorist said, and we're only just realizing we missed the party. So what is JWST really showing us? Ancient galaxies, cosmic mistakes, or a universe that's been speaking a deeper truth all along? One we're only now learning how to hear. Webb's true legacy. When NASA launched the James Webb Space Telescope, the mission was clear. Look back in time. See the first stars, the first galaxies. Understand how the universe began. But what it found wasn't a beginning, it was a contradiction. A series of galaxies too old, too structured, and too smart to make sense. And now we stand at the edge of something bigger. JWST didn't just photograph ancient light. It cracked the illusion that we had the universe figured out. The telescope pulled back the curtain, and behind it wasn't just more space, it was uncertainty. The kind that shakes foundations. The kind that says, maybe, we're not done learning. Maybe we never were. That's what makes this discovery so powerful. It's not just about galaxies or timelines, it's about scientific humility, about the idea that models are only as good as the data they can explain, and this data refuses to behave. It's a call to start fresh, to write new theories, to think bigger, broader, stranger. So what is JWST's true legacy? It's not just an observatory, it's a mirror, showing us how much we don't know, how much more there is to learn, and how the universe, even after all these years, still has secrets it's just beginning to whisper. This isn't the end of discovery, one lead astronomer said. It's the beginning of a new kind of science, one that listens to what the universe is trying to tell us. The James Webb Space Telescope set out to look back in time, but what it uncovered feels more like a message from the future. Each discovery cracks our models wider open, revealing a universe that's faster, smarter, and far more mysterious than we ever imagined. Are we looking at alien echoes, forgotten physics, or something even deeper? A universe we've only just begun to understand? One thing is clear, space isn't just vast. It's wildly unpredictable. And JWST, it's not just a telescope, it's a key, unlocking the biggest secrets we've never known. Subscribe for more. The sky just got stranger.